Hello everybody, Algebra 2. Here is some notes on factoring, quadratic equations or expressions. Day one here, so it's going to be kind of easier factoring, but we got to get this down. So factors are all the numbers that can be divided evenly, right, with no remainder. They go in nicely. So if I asked you what are the factors of 18, you'd say, okay, 1 divides in nicely, 2 divides in nicely, 3, 6, 9, 18. There are no other numbers that divide nicely into 18 that are whole numbers. Greatest common factor is another huge skill. You're looking for the biggest number that is a factor of all the given terms. So it has to be able to go nicely into all of these. Like I could say 3 goes into all three of these. 3 goes into 54, 3 goes into 63, 3 goes into 81. But my greatest common factor is 9 because I cannot find a bigger number that goes into all of them. Like if you're thinking 18, you could try it. You could be like, hey, does 54 divided by 18 work? Yeah, it does. Okay, awesome. How about 63 divided by 18? Still, oh, no, that doesn't go in nicely because it's 3.5. So you can't go up to 18. It doesn't divide into all of them. Okay, so that's a tough skill because it does require you to be good at division or multiplication. Really, it's just multiplication. So first skill to practice is, can you take out what's common to both of these? So the first one, I look at the number part, and then separately I look at the x part. So what can I divide in nicely to 16 and 20? If you say 2, you're not wrong, but you're not right, because although a 2 does go into both those, I can think of a bigger number that divides in nicely, and that would be 4. So 4 goes into 16, and 4 goes into 20. Now when you're dealing with variables, it's even easier because this one, I want to think of that as x times x, and this one I want to think of as just x. So what's the biggest one I can take out of both? I can take out an x. You can double check your work because if I took 16x squared over 4x, I can say, okay, 16 over 4 is 4. I can get a nice number there. I can kill off one of those. Sometimes people try to take too much away. You can't take the higher number, you got to take the lesser that they have in common. What divides into 27 and 72? Pretty sure my first guess would be to say, 9 goes into both, but you should always check what about actually dividing one of them by the other. It doesn't go in. So 9 goes in here nicely. 9 goes in here nicely, so 9 must be the biggest one. You could try 18, right? But 18 doesn't go into 27, so it does in 72. Similarly here, what is common to 18 and 53? I mean, I could try some of the numbers, like 18 is divisible by 1. That's not a big important number. It's divisible by 3, but this, if you've tried it, I already know it's not divisible by 3. Nope. You could try 6. 53 divided by 6. Not happening. 9, not going to work. If it's already not divisible by 3. So these don't have anything in common. So what the heck am I supposed to write if they don't have any common factor? Here's what you write. Relatively prime. It means no common factors other than 1, because technically you can divide 1 into any numbers. So the fancy phrase for this is relatively prime. Awesome. Moving on. So let's check this out. Now I'm asking you to factor these. The first thing you should look for, the first rule of Factor Club, is take out the GCF. We just spent time looking for the GCF. Now I need to take it out. So I need to say, what can divide nicely into 12 and 16? Right? 2 does, but so does 4. So a 4 is the biggest number that divides nicely. And then when I see these guys, they both at least have one A. So I know I can take out a 4A from both those. And by take out, I mean divide out. So think about what would be left from this guy if I divided out a 4, there would be a 3. And if I divided out an A from A squared, you're going to have still an A. On this last guy, if I take out a 4 from 16, meaning I divide it, oh, by the way, see how that plus sign's in the middle? There's still a plus sign in the middle here. So if I take out a 4 from here, I have 4. If I divide out an A from A, it turns into 1. So 3A plus 4. Now, a great way to check if you did it right is when you think you're done, distribute it back and think, you don't have to write it out, but think in your head, what would I get from that times that? 12A squared. Awesome. What would I get from that times that? 16A. Awesome. So if you keep in mind that factoring is just the opposite of distributing, you will be pretty good. All right, now I look at all these. Okay, now I got 3 numbers to deal with. What number goes into 18, 12, and 9? 18, 12, and 9. 9 goes into both of these, but it doesn't go in here, so you can't say it's common. But a 3 goes into all of them. Okay, how about the C's? There's 1 C here, there's 2 C here, and there's 1 C here. So what do they actually have in common? 1 C. Here's 2 D's, 1 D, 1 D. So they have a D in common. So now, in parentheses, what's going to be left over is what happens when I divide it out. So 18 divided by 3 is 6. I divide a C away, it goes away. I take out 1D, so 6D. Take out a 3 from, remember there's a plus sign here. That plus sign goes there. 12 divided by 3 is 4. I take out one of the C's, right? So I get C, and I take out one of the D's, and it just goes away. And last but not least, 9 divided by 3 is 3. There's a plus sign because of that dude. 3, and then I take out one of the C's, and I take out one of the D's, so there's nothing left over. If you want to see, did I do it right? Do that times that. 18CD squared. 12C squared D. 9CD. You can tell you did it right by foiling, or distributing is a better word. Okay, so I'm going to cruise through some of these, and we'll try to get the hang of them. I can take out, oh crap, hold on. I can take out a 5 from each of those numbers, not a 15. What am I thinking? Rookie. Okay, there we go. Problem solved. All I need is white out. If I take out a 5x, there's a 3 left over. There's a plus sign in the middle. I take out a 5x here, divide out a 5x, you get 5x. If you ever doubt yourself, okay, that times that. That times that. Sweet. Got it. In fact, I recommend doing that and then before you circle your answer. All right, now we get to a crazy one. It looks like there's nothing in common, right? This one's divisible by 2, that one's not. This one's divisible by 2, that one's not. But here's a little hint. I'm going to write at the top. If there are 4 terms, try factor by grouping. Whoops. Okay. If there are 4 terms, like here there were 2 terms, here there were 3 terms, here there are 2 terms, here there's 4. As soon as you get to 4, try grouping the first 2 together and grouping the last 2 together. Now I started you off with an easy one because when you have a plus sign between, you can actually just use your symbols. Now, with that, the reason I put it in the same section is when you look at these two, they have something in common. You can't take out a 2 or a 7, but see how they both have an x? What would happen if I took an x out of here? You'd have 2y, and a 7 out of here. Or sorry, an x out of here. You get a 7. Now, what's kind of weird about this, I kind of wish this wasn't the first one we did, but Now, look, these guys, how there's just two terms separated by a plus sign. Now these guys have something in common. I can actually take out a 2y plus 7, and what goes in the parentheses is whatever is left over. If I divide out a 2y plus 7, you get an x. I still have a plus sign. If I divide out a 2y plus 7, most people will write 0 here the first time, but you should realize when I say take out, I'm actually dividing a number by itself, which makes a 1. Now, you can tell you're right by foiling it back out. Same answer, same rules apply. All right. Okay, now going on to number 5. I'm going to, since there's 4 pieces, I'm going to chop them into 2 and 2. And I'm going to take out a 4b from this first chunk. See how there's a 4 and a b? Now if I take out a 4b, all that's left from the first part is a. If I take out a 4b from here, dividing it out makes 8 divided by 4 is 2, and the b just goes away. In the back, they're both divisible by 3. So if I take out a 3 here, it's going to be a plus 2. Now what's kind of cool is, if they both have a plus 2's, I can take out an a plus 2. But if I divide out an a plus 2 here and I divide out an a plus 2 here, what's left over? Oh, just the leftover stuff, 4b plus 3. All right, I'm going to pause. I'll do the next one and show you the answer. All right, here's the answer to the next one. You can take out a 3x from this first chunk, a 9 from the second chunk, and if you steal this one from here and here, right, kind of by like undistributing, then what's left over is the 3x and 9. All right, let me get to the next chunk. This stuff is kind of cool. This is another easy factoring. If there's just 2 terms, you use factor by difference of squares. All right, write that at the top of your paper. If there are just 2 terms, use difference of squares. If there are 4, we'd use factor by grouping. So here, you'll recognize this. If there's x squared minus 4, really I could rewrite that as 4 as 2 squared. If you ever have one thing squared minus another squared, it factors into x plus 2, x minus 2. You write them both without the squareds, and you write one factor with a plus and one factor with a minus. If you don't believe me, go ahead and distribute it out. I guarantee you'll get back to there. So use that same thought here. If I rewrote it, 16 is 4 squared. That means one of my factors will be x plus 4. The other factor will be x minus 4. If I distribute that out, I get x squared. You don't need to do this part, but I'll just show you. X squared minus 4x plus 4x minus 16. What happens when you add a 4x and a negative 4x? You just get, hey, I did it right. Awesome. Similarly, still 2 terms, so I'm going to try it again. 81 and x squared. Okay, so that has a nice square root, and so does that. I can rewrite this as 9x quantity squared. And I can rewrite this as 5 squared. So there are 2 terms. I look to see if they're perfect squares. They are, which means one of my answers is 9x plus 5. The other factor is 9x minus 5. These are kind of nice when you get the hang of them. Same deal here, but don't do it too early. Those aren't squares. If you notice, I should always be looking for a GCF. See how 7 goes in here, 7 goes in here, y goes in here, y goes in here. So I can take out a 7y. I'll be left with y squared minus 4. Now that is really something that factors further. Just don't lose your 7y along the road. Y plus 2, y minus 2. All right, and then the last one, that was the last one, I think. Yes, that was the last one. All right, so it's really easy to lose that 7y. Just let it tag along for the fun. All right, hopefully that made sense. There's 3 different types of problems. GCFs only. If there's 4 terms, do factor by grouping. And if there's just 2 terms, do difference of 2 squares. Talk to you later, people.